This video is for chapter 1.2, observational studies versus designed experiments. Now that we have at least some idea of why we conduct statistics, how we collect data, we now have to distinguish between the two different types of studies. One's called observational, one's an experiment. So in our case, the kind of work we're going to do, because we don't have a lot of time, we'll do more observational work versus actually conducting experiments. And so important questions come to mind in terms of these two things. And in either case, some important words that we need to know are what we call the explanatory variable and response variable. And we'll talk a little bit about that. So let's look at an example real quick of the two different types. One is, here's an example of researchers who wanted to investigate cancer among Danish cell phone users who were followed for up to 21 years. To do so, they kept track of 400,000 people. They recorded the number of people who had a brain tumor and compared the rate of tumors to that against the general population. Okay, and they found no significant difference between them. That's one type of study. And then in this case here, researchers examined whether chronic exposure to radio frequency, radiation to two common cell phone signals used by cell phones, increased basically cancer, and they used rats. So the rats in group 1 were exposed to one type of frequency, and then the rats in group 2 were exposed to another, and then rats in group 3 were exposed to another. And so these are different types of studies. And then after 500 days, the researchers reported the following. After analyzing the data, we found no difference in tumors in there. And so now what we're looking at in both of those studies, the goal of the research was to determine if radio frequencies increase the risk of getting cancer or brain tumors. Whether or not the brain cancer was contracted is what we call the response variable. The level of cell phone usage is the explanatory. Does cell phone use explain cancer, which would be the response variable? And in research, we wish to determine how the amount of the explanatory affects the value of the response variable. And so in this case here, what we're looking at is an observational study measures the value of the response variable without attempting to influence, and this is an important piece there, without attempting to influence the value of the response or explanatory variable. You're just collecting data and observing. This is an observational study versus when a design experiment is when we intentionally change the value of the explanatory variable and see if that somehow changes the value of the response variable. We do something intentionally to the explanatory variable to see if it has some effect. We make some change. And so looking at our notes, we have some questions to answer. In research, we wish to determine how varying the explanatory affects the value of what. In this case, it'd be the response variable. I'm going to fill in some of these, but look at those questions before I write them down, before you write them down for me. So now that you had a chance to look at some of these questions here, what does an observational study measure? It measures the value of the response variable without attempting to influence the response or explanatory variable. We just observe the data. Explain how to determine if a study is a designed experiment. While when the explanatory variable is intentionally changed or altered, we have a designed experiment. We're changing the variable, the explanatory variable, to see if that has an effect on the response variable. And then there's an example here in the notes in the PowerPoint here of this influenza or this flu study. And researchers want to determine the longer-term benefits of the flu vaccine. And what they did is they looked at different groups of looked at records of 36,000 seniors. The seniors were divided into different groups, and they looked at the data. So with that in mind there, this is what we call an observational study because the data was collected through records and the explanatory variable was not changed. And so with that in mind, we can then kind of go ahead and look at some of these other terms that exist here. There's some important things to, when we conduct studies, there's some important things to be aware of, right? Based on the results of the study, would you recommend? So it's what happens sometimes is the data has flaws. the study may have some flaws, namely some what we call confounding. Confounding occurs in a study when the effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between the explanatory and the response may be due to something else, where we say this causes this, but there could be some confounding, meaning that we weren't able to really identify between what variables cause that. Did you get better grades in the class because you went to tutoring, or because you actually started reading your book, right? Which variable actually caused that? There'd be some confounding there. There's another term called lurking variable, as an explanatory variable that was not considered in a study that affects the value of the response. So we conduct some study, and then we don't even think about what can explain something, and those are called lurking variables. So let's get those down in our notes. So to finish off this idea here are the answers to these questions here. We continue on with, again, finishing up with define confounding in a study when the effects of two or more explanatory variables is not separated. We do not know what is influencing the response variable. That's when we have some confounding. That's different than what's called a lurking variable, which is an explanatory variable that we did not consider in the study. That was not considered. We didn't think about how that could influence something. And then that's what and that leaves us with defining a confounding variable, which we have here. And then, right here, what are some lurking variables influence a study? Back to that original notes we had here. Some lurking variables: age, health status, mobility of the senior, right? It just wasn't maybe, those are things that were not considered, and why some of the results you would get, those would be considered what we call lurking variables. And so you want to keep that in mind. We finish this section with, there's some other, we're not going to do them in these classes, but it's just good to know them: cross-sectional studies, case studies, cohort studies, which we talk a little bit later in chapters, but in general, those are other types of studies that we have here: cross-sectional, case studies, cohort studies that we have when you do, but those are more advanced techniques for more advanced statistics. For those of you maybe going on and having to take another stats class and actually collect data or get your master's degree, you would have to do something like that. And then to finish this off, it's not always possible to conduct an experiment. Explain why we would not conduct an experiment to investigate the perceived link between high tension wires and leukemia in humans. Again, we can't always conduct experiments because in these cases, these are unique situations. And on these cases here, we wouldn't do it because we're endangering, I would say, people's lives. And the last term here, what is a census and why is the U.S. Census important? That's when we collect data. Here is what a census is: a list of all individuals in a population. That's what a census is. And so we could end on that. A list of all individuals in a population. And so every 10 years, the United States tries to conduct a census where they try to collect data, demographic data on everyone in the United States. That's why it's called the census, but that's what a census is: a list of all individuals in a population.